Good morning, boys and girls. Today we have 2 experiments, and what you're going to be required to do for science class today is take a picture of each experiment. Okay, so 2 experiments, 2 pictures. That's what you're going to post today. Now, the 2 snowy day experiments that I have for you are fun, and you're going to learn a little bit more about the density of solids, liquids, and gases. Solids, liquids, and gases. Their density, how close together the molecules are, because remember it goes solid, they're pretty close together. Liquid, the molecules are a little farther apart. And then with a gas, that's where they're the farthest apart. And remember when we were running around the room and we were little molecules running around? If we were hot, we moved faster and we spread out. If we were cold little molecules, then we got closer together. We got more dense and we move more slowly. So keep those ideas in mind as we look at the 2 experiments we're going to do today. The density of solids, liquids, and gases, and how temperature affects those densities as well. So for our first experiment, you need to find something that you can blow up. Something not like blow up like chemistry, blow something up in a lab kind of thing, but something that you can blow up, okay? So it could be that you might have some balloons at your house. So maybe you have balloons. Now this is a rather oddly shaped balloon, so I tried a different one because I thought that's just very oddly shaped. I had 2 yellow balloons, and one was pretty average. The other one was really odd, so I was like, those 2 aren't going to work. So I got 2. Hi, I'm still here. I got 2 that are about the same size, and those would classify as things you blow up. If you don't have something like that, if you don't have balloons at your house, you may have something like this globe. I got the whole world in my hands. Oh, sorry. This globe blows up. That classifies as something that blows up. You might just have a little glove that you can wave at people with. I blew that up. It can be blown up, those little gloves. And if you have nothing else to blow up, you can even, I'm still here. You could even blow up a baggie. Looky there. That baggie blows up. You could have a basketball. I'll bet some of you have basketballs at your house. Basketballs classify as things that blow up. So anything that blows up, I want you to blow it up in your house, inside. And then, and when you have it blown up inside, make sure that it's nicely blown up. It's nice and firm. You get that thing really blown up. And then take it outside into the cold, nasty weather. Stay out there for just, 5 minutes, 10 minutes. If you don't want to stay out there with it, just put it out where you can see it and go get it in a few minutes. Or if you don't want to go outside at all, if you're nice and cozy by a nice warm fireplace, and I hope you are nice and warm, I hope everyone is well. But if you don't want to go out there and get your tootsies all cold, then you might want to just use something small. Where did my baggie go? There it is. I threw it on the floor. You could use something small like a baggie and just put that in the freezer. That would work too, because the freezer is freezing cold. Yeah. It's really cold. So you could take like your baggie, and I just left one little corner open and blew up in that one little corner and then closed it. You could take your baggie and stick it in the freezer and see what happens. So I'm going to give you a minute now to blow your things up. So you can pause this video and go get something and blow it up. I'm going to sing a little song, but you can pause me. Just hit pause or stop or whatever. But I'm going to sing a little song. Do 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 do. Oh, surely you've got your thing now that you were going to go blow up. So now that you've got it all blown up, you're going to take it and put it into the freezer or outside, and I want you to watch what happens. I'm going to pause again. You can hit pause. But I'm going to go, do, 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 do. Take your thing that you blew up outside. Okay, so now we're back. Hopefully you took your thing outside, you left it there for 5-10 minutes, or you took it to the freezer. If you don't want to go outside, maybe you took your little baggie or little teensy balloon and put it in the freezer. What happened? Well, if you remember, when molecules get cold, what do? They get closer together. So when you took your thing that you blew up and you took it outside or put it in the freezer, what happened? The molecules got closer together on the inside. They condensed. They became more compacted. They moved more slowly. And then that probably made your object shrink a little bit. If it was a basketball and you tried to like bounce it, once you took it outside, you might have gone, oh, my ball is so low. I got to blow this thing up again, man. It happens with tires. Like I went out and took my car out after it got really cold and it said, your tires are low, or some little thing up on my dashboard. It said, your tires are low, or something like that. Because when it got really cold outside, it made the air in my tires condense, and they just happened to be a little bit low after that. It happens sometimes in the colder weather. Another thing that can happen, the other day we had this travesty. I blew up the snow things, the inner tube, snow tube things. Blew them up in the house, took them outside, and of course I used my hot air. I'm full of a lot of it, you know what I'm saying? But I blew those things up, and I took them outside, and then Nate and Ben were like, Mommy, you didn't blow these things up. Yeah, I blew them all the way up, I promise. And then it hit me. The cold air condensed the molecules. So even though I'm full of a lot of hot air, it's cold outside. All right, second experiment. So don't forget to take a picture of your experiment. If you want to take a picture of just your blown up object, that's fine. You could, if you want to do a before and after, that's fine. Now, to make it a true experiment, you would want to leave one balloon in the house while you take one out into the cold and then see what the difference is. Because remember, in an experiment, you're going to have that independent variable. It's going to be the one thing that changes, right? So the thing that I would change is take one of them outside into the cold, change its temperature. So if you were truly going to do an experiment, you would do two objects and leave one out in the warm air and then put one into the cold. You don't have to do that today because we know that the one that stays in is probably going to stay about the same. Okay? But just letting you know, tomorrow there may be questions about this, and it may ask things like, what's the independent variable? Well, it's a balloon that I would either leave outside or leave it inside. What's the dependent variable? Well, you could measure how much smaller the object gets. Remember, the dependent variable is a measured outcome, something you can measure at the end to see what changed. So at the end, we could maybe measure the size of the balloon, like how much smaller is it now, measure it when it starts and then when it finishes. That would be a good dependent variable. And then you got to think of things like constants. Like I tried to use the same kind of balloon. I even used the same color. Not that that necessarily matters, but I tried to use the same brand. I tried to blow them up to be about the same size. Constants are the things that you keep the same for both balloons, even though you took the one outside and that was your independent variable. What changed? All right, and then what's the other thing? The control group. That would be the one that gets no extra stuff. So that would be like the one that we just leave inside. It doesn't get any temperature change. It just stays inside. It doesn't have anything special happen to it so that we can compare the other balloon to it. The control group is the one that gets none for it. None of the independent variable. All right, so moving on to our second experiment. I'm going to start a new video. So when you're ready to do the second experiment, just click on the second video.